And as I have told earlier, the transmission line theory, the delivery of power from the source to the load. So at lower frequencies, the power is delivered, right, through the wire, right? The current flows through the wire, the potential difference is available, so the power is delivered. And of course, most important aspect of this is whether it is a low frequency or high frequency, the efficiency of power transfer is very important. So as you have studied in circuit theory, we talk about maximum power transfer, how effectively we transfer the power from the source to the load. So we need to make it more efficient so that maximum power is transferred. So in the case of circuit theory, the power is delivered through the components, but in the microwave region, the power is considered to be electric and magnetic fields. They are guided from one place to other. So any physical structure that guides an electromagnetic wave is called a transmission line. This is very, very important. So this is the basic aspect. So now, what is the difference between the low frequency and high frequency? Why there is a difference description of power transfer? So at low frequencies, the circuit elements are lumped. So I hope you recollect the basic series of basic network theorems like Thevenin's theorem, Norton's theorem, so on. You introduce a word called a lumped element. That means in circuit theory, we introduce resistors, capacitors, and inductors, which are lumped. Lumped means they are concentrated on a particular location, and the voltage and current affects the entire circuit at the same time. That means there is no time delay between the components, or otherwise voltages and currents are instantaneously applied to all the components in the circuit. This is a very important assumption, and it is valid at low frequencies. At high frequencies or microwave frequencies, such a treatment is not possible. Why? Because voltage and current waves, they don't affect the entire circuit at the same time. Why? Because the dimensions of the components become comparable to the wavelength. Because at higher frequencies or microwave frequencies, the waves cannot be instantaneous. For example, if the wavelength is 1 centimeter,